We're going to solve the following problem. Use the distance formula and the Pythagorean theorem to find the distance between the points 1, 1 and 5, 3. And we're going to simplify our solution. First thing I'm going to do is I'm going to plot my points in any order. I'm going to plot 1, 1. And I'm going to label this x sub 1, y sub 1. I'm going to plot my second point, 5, 3. And label this x sub 2, y sub 2. And then what I'm going to do is I'm going to connect the 2 points with a straight line. And that line is what I need to find the distance of. So the first formula that I'm going to use is the distance formula. And the distance formula states that in order to find the distance, I will take the square root of x sub 2 minus x sub 1 squared plus the square root of the quantity y sub 2 minus y sub 1 squared. And I will substitute in, as we did in algebra, I will substitute my numbers in here. My x sub 2 is 5 minus x sub 1 is 1, the quantity squared. The same thing with the y values, 3 minus 1, the quantity squared. According to my order of operations, I am going to do my parentheses first. 5 minus 1 is 4 squared. 3 minus 1 is 2 squared. And when I solve this, I will square both parts. 4 squared is 16, plus 2 squared is 4. And I'm going to add. And I get 16 plus 4 is 20. Now when we rationalize, as we did in the last unit, I'm going to break 20 down into numbers, primes or perfect squares. 20 is the same thing as 2 times 2 times 5. And for every 2 numbers that are the same, I pull those numbers out and I write it once, and I get 2 square roots of 5 for the length of that segment. Now, in order to use the Pythagorean theorem, what I can do is find the other 2 sides of my triangle. And we know with the Pythagorean theorem that a squared plus b squared equals c squared, where c is the hypotenuse. So what I'd like to do is I'd like to connect my first point with a horizontal and vertical line to get to my second point. So I'm going to draw a line from 1, 1 directly to the right until I get right beneath point 5, 3. And I'm going to do the same thing vertically to connect the 2 points. I now have a right angle and a right triangle, and according to the Pythagorean theorem, I know that the hypotenuse is C, and my other 2 sides are A and B in any order for A and B, doesn't matter. And I'm going to find the distance between A and B. So the first thing I need to do here is this. I need to look at the x values of my first point, which are 1 and 5, and I subtract those to find the length of A. 5 minus 1 is 4. Or I can just count how far it is across the horizontal. I do the same thing for the B value. I take the y value, which is 3, minus the other y value, which is 1, and find a length of 2. And I'm going to sub A and B and C into my problem. So A squared plus B squared equals C squared. So 4 squared plus 2 squared equals C squared. 16 plus 4 equals C squared. And I'm going to just add. 16 plus 4 is 20 is equal to C squared. In order to the rules of algebra, I square root both sides, and I get that C is the square root of 20. And as we previously have seen here, the square root of 20 is the same thing as 2 square roots of 5. So either way to do this problem would be fine.